In this video we're going to have a look at another more difficult example of arithmetic series calculation. Okay, it's question 2. It follows on obviously from the previous video where we looked at the first of the harder questions. The sum of the first 5 terms of an AP is 70, the fourth term is 12. So, okay, we've got to find the first term, we've got to find the common difference. Very straightforward, basic process. The sum of the first 5 terms, so S5 I know is 70. You're told the fourth term is 12, so I know that T4 is equal to 12. Okay, using the two formulae that you know for the sum of n terms and the nth term formula, which if you want to, you can work out at the side, we can now replace values T4 and S5 with an expression involving A's and D's. So for example, we know that the nth term formula is Tn equals A plus n minus 1 D's. So if we're talking about T4, the fourth term, T4 will be the same as A plus, well, 4 minus 1 is 3Ds. So A plus 3D is the same as T4. So I'm going to change T4 there to A plus 3Ds. And that's equal to 12. And that's an equation with two unknowns in. I can't solve it. So as I did last time in the previous video, I'm going to call that equation 1. Right, S5 equals 70. Let me make a bit of space and go over here. S5 is equal to 70. Well, the Sn formula, the sum of n terms, is n over 2 bracket 2a plus n minus 1d, like so. So if I want S5, n is 5 then. So I'm looking at S5. So it's 5 over 2 bracket 2a plus 5 minus 1 is 4d's. So I get S5 equals that expression there. So I'm going to change in this statement up here S5 into that thing there. So I get on the left 5 over 2 bracket 2a plus 4d's, and that's equal to 70. Like I did I think in the previous example, there's a common factor of 2 that I can take out to the front, and when I do that, this bracket then becomes just an a plus 2d. The 2 gets taken out to the front, and then it will cancel the 2 that's already on the bottom line outside. So if I cancel, I just left with 5, like so, and that's equal to 70. Now in this particular one, 70 is a much more friendly number to be looking at, so I can share that by 5 just to leave a plus 2d on the left, and I'll share that by 5 as well. If I share it by 10 I get 7, so share it by 5 I'd get 14. So there you go, there's a second equation. A plus 2d is 14, a plus 3d equals 12. We've got two very simple equations which we can solve simultaneously. So easy, and in fact I can probably just do it here without rubbing anything out. So I'm going to solve here now 1 and 2. I'll do it by substitution. Okay, so number 1 is going to give us that a is equal to 12, take away 3d. Take the 3d over, it becomes a minus, and I'm now going to substitute that value of a into equation 2. So therefore equation 2 is going to become this, a plus 2d. So a is 12 minus 3d, that's what a is, plus 2d, plus 2d's are equal to 14, So we get that. Well, if you put the d's together, you're going to get a minus 1d on the left. So take it to the right, you get d on the right, positive d on the right. And then take the numbers to the other side, you're going to get 12 on the left. Take the 14 to the other side, you're going to get 12 minus 14, you're going to get a common difference of minus 2. So there you go, common difference of minus 2. Okay. Next, if d is minus 2, therefore, if we go to, where are we? This one here, which I'll highlight with an asterisk. Asterisk line now is going to give us that a is going to be equal to 12, take away 3d's. So to take away 3 lots of d, be careful, is negative 2. So you get a is equal to 12 plus 6. A turns out to be 18. And there you go, I hope you can see that. A equals 18 is the answer there. So the first term is 18 and the common difference is -2, and there's the end of that question. So, okay, a second typical example of a harder type which involves simultaneous equations.